Good afternoon from Kreuzwerker's office in Berlin, and welcome to our webinar on modernizing Java applications with Kotlin. I can see a few participants joining in. We will wait for 2 or 3 minutes to give everyone an opportunity to join in, and then we'll basically begin. And to fill in this particular time, we have some poll questions for you because everybody loves poll questions, and I'll be launching them right now. It would be good to know more about you and know more about your overall experience, your familiarity with Kotlin, and what it is that you're using in your development environments nowadays. So the main agenda of today's session is to understand the following points on why would you want to move to Kotlin? When would be the correct timing to think about such developments and migrations? How do you successfully transition to Kotlin? And finally, we'll be having a dedicated slot for question and answers at the end of the session. A few organizational points that I would want to share with you in the beginning are that we are recording this webinar, and we'll be sharing the same with you at a later date, along with all of the slides that we use today. And in case you have any questions, you can please feel free to use the question and answer box. We will try our best to answer them in the dedicated time at the end of the webinar. And in case we run out of time, we will get back to you on the same with an email. With that out of the way, let's first have a round of introductions. Starting from me, I am Gopal, and I work as a software development consultant, specializing in backend technologies with more than 6+ years of experience in technical product design and development. I have some experience in leading teams, translating business user needs, and also in technical training. Our other speakers here today are Katrina and Thomas, and I will now pass the baton to Katrina for an introduction.
Thanks, Gopal. Hi, everyone. Welcome. So my name is Katerina, and I've been working in software engineering for the past 10 years, 2 of them as a consultant. Throughout this time, I had a chance to be part of teams that follow you build, you run it approach, and this allowed me to gain experience in software engineering, architecture, and cloud technologies. As a consultant, I love challenging projects, and I always strive to deliver the best solution to my client. And Thomas.
Yes, hello. My name is Thomas Wensinski. I'm also a full-stack software engineer working for more than 10 years in the industry. I'm working now for 2 years as a consultant, and I try to get Kotlin to the teams I am working with. Usually I try to get the language to them because I'm really convinced that it is a fun and good language. Yeah. Regarding myself, I am especially also interested and working in topics around domain-driven design and software architecture, and happy to have the webinar with you today. I hand back over to Rupa.
So thanks, Thomas. Just a little bit more about us and all of us. By that, I mean the speakers here today. We represent Kreuzwerker. We were founded in 2012, and we are an AWS partner since the last 10 years and fully committed to AWS and all the things and services that we provide. In Germany, we have offices in Berlin and Frankfurt, and we are also present in Warsaw and Zurich. Our services majorly centered around migration and modernization. We also do a lot of cloud-native software development and help customers modernize their application landscapes, which is exactly why we chose the topic at hand today. Now that you know us better, I'm sure most of you want to dive into the content. And the first question for that would be in your mind, why would I want to shift to Kotlin? And we would be answering this question as true consultants with questions. So have you wondered why your Java class looks like a God class when all you're trying to do is perform a basic operation like reading a file? Or does a bug in your huge code base make you sweat and you're lost on line numbers and stack traces? Or maybe you're bugged by your development efficiency and the maintainability of your code base? And if you're answering yes to any of these questions that I'm asking, then it might be time to consider making the switch to Kotlin. Because Kotlin as a programming language addresses some of the most significant issues that developers have experienced with Java in the past. But first, no presentation is complete without introducing Java in the most monotonous way possible. So Java is a widely used object-oriented and class-based programming language known for its platform independence, making it suitable for a wide range of applications, from desktop software to web applications and mobile applications. It was developed by Sun Microsystems. It's known for its write once and run anywhere capability, allowing developers to write code and run it on multiple platforms. I believe none of us are strangers to Java here. And to just know a bit more about you, it would be great if you could answer our current poll, wherein which would be the oldest version of Java that you have used. And it should be visible to you now. I will start by saying that for me, it's Java 1.3. Yes, I am that old. So while that poll runs in the background, I would continue with why Java, because 28 years since it's released, which is almost all of my life ago, Java is still one of the most widely adopted programming languages in the world. It's powering countless applications across industries and platforms because it offers platform stability, which we can see here. It also has a wide adoption rate, which is as seen in this particular graph. It has a large developer community, which means there are abundant of resources and support available for it. It is also known for its high performance and efficient memory management. It also offers a strong backward compatibility. And finally, it has mature tooling and robust IDE support. I would also be answering, or I would also be closing the poll now. I can see that for a lot of you, it's greater than 1.4. Okay, so I just realized what my age is. But cool. Thank you so much for answering. And continuing forward, now that we understand why Java is still being used, you might say that why are we here? If everything is so perfect with Java, then what about Kotlin? Well, Kotlin was not specifically designed to remove Java's flaws, but rather to address some of the shortcomings of Java while providing additional modern language features. It was developed by JetBrains, which is a statically typed programming language that runs on the JVM and allows you to choose between a class-based approach or a functional approach for coding your applications. It offers several features that are designed to improve upon Java and write more concise and expressive code. Now, Kotlin has gained popularity due to numerous features, but Java's strength is that it continues to maintain compatibility with older Java branches. Let's have a look at what Kotlin offers when it is compared side by side with Java in order to understand this topic a bit better. Any guesses on what's the biggest selling point could be? Well, it's the concise syntax. Java can be verbose, and it requires more lines of code compared to Kotlin to achieve the same functionality. This can make the code base larger and harder to maintain. It, by default, also requires more boilerplate code for common tasks. And as a developer, I feel zero guilt for having to admit that I hate writing getters and setters. And sorry, I do not want to learn any fancy shortcuts to generate them quickly. Even if I do, the entire process of generation makes a more code base repetitive and error-prone. Kotlin, on the other hand, has a more concise and expressive syntax as compared to Java, reducing this boilerplate code. Let's have a look at a few examples. As we can see over here, we can see that this is the most Java class ever. It's a POJO, which requires developers to manually write getters and setters for each property that you can see over here. For some of you, what you're going to see now might be the first Kotlin code that you have ever seen, but I present to you a data class. Data classes in Kotlin are automatically generated with a concise syntax that include getter and setters and other methods like equals, hash codes into string. The key point is that they are a native language feature, which is fully integrated within the language. They help reduce the boilerplate code, which is visible over here. And it also helps to improve your maintainability, especially in projects in which you're writing POJOs and DTOs again and again and again. Now, some of you here might question, why is this guy bashing Java when there is Project Lombok? To you, I would say, yes, it exists, but it introduces an additional dependency to your project, which requires updates and maintenance in line with your project's lifecycle. Whereas Kotlin offers this as a native language feature. Moreover, not all IDEs provide seamless integration and support for Lombok's generated code. But some of the more advanced Java users here, which I understand a lot of you are, would say that, Gopal, Java 14 added a new feature of records. Isn't it somewhat same? To you, I would say yes, it is quite similar, but it enforces the final keyword for variables, making them immutable, while not offering a copy method for your object creation. So I hope you realize that the devil is in the details. Another small example is the singleton object in Kotlin. In Java, there is no direct equivalent to Kotlin's object keyword for defining singleton objects. It requires additional boilerplate code, as you can see here, to achieve the same effect. The key takeaway here is that whatever you can achieve in Java, Kotlin can do it in fewer lines of code. Now let's talk about null safety. Java lacks built-in null safety features, which either leads to bugs or an increase in the effort of writing more verbose code to handle it properly. Java offers the optional keyword as a part of the SE8's optional class, which can be used to wrap a value that may be null. But it provides methods to handle those null values in a more functional way. But these additional method calls to wrap and unwrap values, as I said, can be again verbose. Kotlin type system, on the other hand, is aimed at eliminating the danger of null references, also known as the billion-dollar mistake. How does it do that exactly? Well, you can see it over here. By default, each variable in Kotlin is non-nullable. In order to assign it a null value, a developer has to consciously use the question mark symbol that makes a variable nullable. This helps prevent null pointer exceptions through its system at compile time. To access this particular property, you need to use a safe call that is depicted in the code above. These can even be chained together. And the best part is, in case any of these properties is null, then the expression to the right is not evaluated at all. In contrast, Java's optional keyword relies on developer discipline to handle null values correctly. Finally, I'll be running another poll for you guys. Can I get a quick show of hands on how many people here have faced issues whenever they were doing anything remotely thread-based? I'll be launching it right now. And while that runs in the background and I understand how many of you have ever had pain, I would say managing threads can be complex and error-prone, with challenges such as race conditions, deadlocks, and synchronization overhead. Kotlin's coroutines, on the other hand, provide a more lightweight and efficient way to write asynchronous and concurrent code without the additional overhead of handling concurrency related to error management or interprocedural call. Let's have a look at the example. So, coroutines are not tied to any specific function. If you can see, they allow developers to write asynchronous code in a sequential and more straightforward manner, using familiar control flow constructs like suspending functions in async and await style syntax. Coroutine builders come in two flavors: the ones which can propagate exceptions automatically, or the ones which expose them to users. In this example that we see over here on the screen, the Java code uses two threads to run two tasks concurrently, whereas the Kotlin code uses coroutines to achieve the same concurrency with the launch function. As always, the Kotlin code is more concise and does not require explicit thread management functions or synchronization. This is all built in, making it less error-prone and easier to understand. One can also still fully utilize threads due to Kotlin's interoperability with Java, but coroutines build a feature set on top of this, which allow for non-blocking IO-like concurrency. I'll be ending the poll right now, but I see that the majority of them hate them. Some of you feel that it's smooth as butter, and I'm honestly surprised, but it's good. Cool. So to continue back and get back to the material that we have in place, I can imagine most of you are thinking right now that if all of this that I've told you right now is enough to push you towards using Kotlin in your projects. But before you fall into this dilemma, let me explain some more key features of Kotlin that can maybe make your life and decision easier. So Kotlin supports features such as Lambda expressions, extension functions, and DSLs, which can really improve your code's readability and maintainability. Let's have a look. Lambdas have been around since Java 8. Let's compare an example of fetching even numbers from a list. In Java, we would use the stream method to convert the list into a stream. And then we use the filter method to collect these particular numbers on the ones which are even. And finally, we would use a collect method in order to collect this new list or array list that we are going to have. In Kotlin, on the other hand, you can directly call the filter function on the list and provide the lambda expression as a parameter using the curly braces syntax. The it keyword refers to the current element being processed. So we can directly use it instead of explicitly declaring a variable name like in Java. I believe that Kotlin eliminates the need for an explicit stream conversion and provides a more intuitive syntax for lambda expressions. In my opinion, this syntax is more simpler and it is more focused on the task at hand once you get used to it for sure. On top of this, Kotlin provides an enhanced collections API with useful extension functions that make working with collections even more convenient and expressive. As seen in the example above, where we are trying to do some string manipulation, extension functions can be added. Extension functions can be added to these existing classes, even the string class for that matter, without modifying their source code, which allows for more expressive and reusable code. Java, on the other hand, does not support any extension functions. So developers must use traditional object-oriented techniques such as inheritance and composition to achieve similar functionality. Using the previously defined features of extension functions and lambda expressions, Kotlin also allows for the creation of domain-specific languages. A DSL is a specialized language tailored for specific domain or problem space, allowing for concise and expressive syntax. In the example here, we basically define a tag class within Kotlin that represents an HTML element. We use operator overloading to provide a concise syntax for defining the tags and their attributes. The invoke operator functions basically allow us to add attributes or nested tags to a parent tag. The HTML function serves as an entry point for our DSL. It creates an HTML tag and applies the provided block of code to it. The block contains our DSL code that you can see over here for defining our HTML structure. This allows us to define HTML elements in a structured and intuitive manner again, closely resembling the actual HTML syntax in our code. The generated output for something would be like this. Now, I would say and argue that this results in code that is easier to read, write, and maintain rather than putting it in another Java class, which would have given you more dependencies. Now, for the die-hard Java fans who have been holding their breath, I would like to end this section by highlighting that Kotlin is fully interoperable with Java. This allows for seamless integration with existing Java code and libraries and makes it easy to adopt Kotlin in an existing project without having to rewrite your entire code base. I believe this should motivate you to give it a try, but with just everything else in life, this comes with its own challenges, like steeper learning curves, some issues with build speeds and tooling, but these will be covered in the coming sections. And for now, I leave the stage to Katrina.
Thanks, Gopal. Yeah, so why now we know why. Let's talk about when should we switch to Kotlin. And moving to Kotlin can be a beneficial decision in various scenarios, depending on the context of the project and your team's goal. Let's explore two different scenarios and discuss advantages and challenges of each of the approaches. So depending on at what stage of the development your project is currently, you might face different set of challenges or get more advantages in one or another case. Here, in both cases, we are talking about the scenario when you already have an existing team of Java developers that is well functioning and building or have built in the past some product of the system. And if your team is about to start a greenfield project, this might be your perfect opportunity to introduce and explore a new programming language like Kotlin. Unfortunately, we don't often get a chance to build something entirely from ground up, and you would have to wait for too long to get this chance. Therefore, you might be considering, it might be worth considering the introduction of Kotlin into an ongoing project or even migrating your existing Java code to Kotlin. Obviously, after carefully assessing the benefits it can offer versus the challenges that accompany this transition. Let's first have a look at the common challenges that you and your team have to be aware of and ready to face. Learning curve. As Kotlin has its own syntax and features, there obviously will be a learning curve for your team members who are not aware of, not familiar with the language at all. Proper training and resources should be provided to the team to get up to speed with Kotlin. While Kotlin has a growing ecosystem of libraries and frameworks, it may not have the same extensive range of tools and libraries as Java, which has been around for a longer time. And some specialized tools or libraries that are widely used in Java may not have an equivalent alternatives in Kotlin. And this will require your developers to find workarounds or implement common solutions, custom solutions, sorry. And similar challenge might occur when it comes to finding answers to specific Kotlin-related questions or getting help with very advanced topics. It might be slightly more challenging compared to Java. However, Kotlin community is continuously expanding and is pretty active. More resources and expertise are becoming available for you. And you can always find required support on the platforms like Stack Overflow, Dev Community, and Kotlin Forum. And yeah, Kotlin community even has its own Instagram account. Last but not least, you should be prepared to have a potential impact on recruiting and team building. While Kotlin has gained popularity in recent years, Java still remains one of the most widely used programming language with a larger talent pool of experienced developers. Finding developers with extensive experience in Kotlin may be relatively harder compared to Java. And while the majority of Kotlin developers, around like 31%, yet have only 2 to 4 years of experience. Although there is a positive trend of developers staying with Kotlin for a longer time. And according to the JetBrains developer survey from the last year, the number of people using Kotlin for more than 4 years has doubled since 2021. On the positive side, introducing Kotlin into a project will definitely make your current team members happier because they will have an opportunity for professional development. Developers like Kotlin. And in most cases, they are people who bring language to their companies and teams and persuade their management to adopt it. At the same time, you will have a chance to attract new talents into your team, people who are enthusiastic about working with modern languages and are eager to learn and adopt new technologies. According to the Stack Overflow developer survey from 2022, Kotlin is winning Java on the scale of the most loved languages, with over 63% of developers saying that they want to continue using it. And when we have only 46% for Java, and over 8% of developers who are not developing with Kotlin at the moment express their interest in trying it out, when it's only around 5% express their interest in Java. At the same time, using Kotlin, you can substantially decrease the amount of time invested in writing repetitive code, thereby resulting in enhanced productivity and reduced development time. And additionally, with the help of the functional programming constructs supported in Kotlin, such as higher order functions, lambda expression, and extension functions, you will enable your developers to write more flexible and reusable code, enable easier testing, and encourage better modularization. Coming back to various stages of the project. One significant advantage of implementing Kotlin in a greenfield project, as opposite to introducing it midway through a project, is the advantage of starting with a clean state. This allows you to build the entire application without any legacy code or dependencies on Java. And when starting from scratch, you can also fully leverage all the advanced features that Kotlin offers, such as extension functions, null safety, and data classes. On the other hand, introducing Kotlin midway through the project allows for a gradual adoption of the new language. This also enables your developers to leverage the strengths of both languages and take advantage of Kotlin's features where it provides the most value. Opting for migration of Java code to Kotlin also presents an opportunity to address the pain points and challenges within the existing code base. The code can be optimized for better performance, readability, and maintainability. At the same time, whether you plan for a full migration of the Java code or not, introducing Kotlin midway through a project will require factoring or rewriting parts of an existing Java code base to make it compatible with Kotlin, and this whole process can be time-consuming. A common example for this is the usage of checked exceptions. Kotlin does not have checked exceptions like Java, so when using Java methods that throw checked exceptions in Kotlin, you may need to handle or rethrow them even if they are not relevant in Kotlin's exception handling model. Another often underestimated aspect of adopting a new language is the significance of communication and collaboration among team members. Coordinating the adoption of Kotlin midway through a project will require an extra effort to ensure consistent coding practices and maintain project stability. You will also need a thoughtful strategy for gradually refactoring your Java code in case you plan to migrate an existing code base. Lastly, the process of migration can introduce new bugs to the application. The risk arises due to differences in language syntax, semantics, and behaviors that exist between Java and Kotlin. And it's important to be mindful of these variations to minimize potential issues during the migration process. So now, keeping in mind all of the risks and advantages we've just discussed, I will now hand over to Thomas, who will guide you through a successful transition to Kotlin.
Thank you very much, Katja. And yeah, let's come to our final part on how to successfully transition to Kotlin. As we heard earlier, we have these two scenarios, right? Like starting a new project and introducing a midway migration. Introducing midway, yes. And we want to have a look at both of these options and see, okay, how would we approach that? So we start with the greenfield situation. So let's assume you are a team that already has gone through some adventures together. You know each other. You maybe know your strengths, weaknesses, and you are going to deliver a new service. There might be new requirements. A new domain has been opened and you're going to deliver a new service for that. What would we do? We show you this little plan that you can rely on, like 5 simple steps, which you can take as an orientation in order to do such a new project starting with Kotlin. And one thing that should be done very early, or maybe definitely at the very beginning of it, is to plan it. And what do we mean by plan? It means that you take an active decision with the buy-in from the team and the management, whether you approach this new project with a new programming language or not. You know, when starting a new project from scratch, there are usually lots of decisions to be taken. Maybe you need a new CI/CD solution. There are other technical decisions that depend heavily on the domain that you are dealing with. There are business decisions to be taken, and as we learned earlier from Katja, right, there's also a certain learning curve in adopting a new programming language. So what definitely makes sense then is to reflect upon your capabilities and resources together with the management and the teammates, whether to take the step of introducing a new programming language. Then we would recommend to us a small training, everybody on its own, as a team, as you like it. On the other hand, our experience is to not overdo it. Do not, lock yourself away for 2 weeks or even more, doing basic Kotlin training and then go ahead and start it. But it's mainly to get an overview, get a feeling for the language, have an exchange, and then do not take too much time on it. And it would also, for example, be helpful having maybe some external resource or somebody in the team that already has experience with Kotlin, because that can also save lots of time when you have a person on board that maybe can solve an issue in a minute and you do not have to, I don't know, research for an hour or something. This can also add up. Another thing which doesn't have too much to do with the programming language itself, but like with the environment we are working in, right, is what kind of culture are we dealing with? What kind of culture are we working in? And it definitely helps having kind of a DevOps culture, having a culture of no silos, having a culture of open knowledge exchange, doing pair programming, mock programming, bringing all the knowledge together in a group and then approach the challenges together, and having in the same run also the knowledge exchange can be really, really helpful, especially also when adopting a new programming language. And then you just start, right? You just do it. You can reuse lots of knowledge that you already have from the Java ecosystem. As we heard earlier, okay, there might be not too many, or the situation regarding hiring market might look a bit worse for Kotlin than for Java. But when you are capable of hiring the right talents, then also a Java developer won't have too much of a hard time to deal with Kotlin. So yeah, just do it. And then you can slowly evolve, right? You might do some stuff the easy way or the native way, how you might be used to do it in Java. But then you find out, okay, there's an easier way, there's a shorter way, there's a more elegant way to do it in Kotlin, and then you iterate over it, which you usually do anyway in implementing software, right? It matures over time, and the same might be also the case for language features in Kotlin. Now let's have a look at introducing a project midway. So let's assume we are a team, you are a team that already has also some adventures done together. You own a zoo of domains and services, and now you are creating a new feature to an existing service. So you are familiar with that service, and it is fine. What should be the plan? It should be the same as we had before, right? So these steps, they would also apply here. But additionally now, we should have kind of a plan, an integration plan. What do we want to migrate first? Where to start? What parts of the application do we want to transform? Maybe alongside with a new feature, we see the opportunity to enhance the readability and understandability of the code that might be rotten already over the time, and now it's a good opportunity to go ahead and change that, and maybe do a refactoring alongside, right? And it comes with some points, I think, to consider, because not all the parts of the code base might be a good fit for a migration. But in a second, more about that. So what we would also need to do is address legacy code dependencies, because now when we introduce only parts of it, then we also need to ensure that frameworks that we are using are still compatible. This is also something Katja mentioned earlier. So for an example, You might know from the Spring ecosystem, the JSON transformation framework. It's not out of the box compatible with Kotlin code because these getters and setters, for example, or the constructors are reflected differently. And so you might need to add some more dependencies or change dependencies in order to make them also interoperable with Kotlin. That's something to address. And you need to adapt your own source sets maybe for interoperability. So you have parts in Kotlin, parts in Java, and you want to integrate these with each other. There might be some adaptations also necessary and taken into account. Usually it's not too much of a big deal, but that also depends on your integration plan. So which parts of your code base do you transform first? A simple example for this interoperability would be accessing static functions from Java and Kotlin, right? So usually you have this companion object where your static artifacts are living. And for example, you would need to add a JVM static annotation to the function so that they are easily accessible without the companion intermediate object. There are some more annoying problems possible. For example, if your Kotlin code calls a Kotlin interface, but this interface is implemented in Java, then yeah, this can cause also trouble. And for that, having this integration plan helps to avoid these kinds of problems. So let's have a look at this at this little package diagram here. So we see two green packages and one red, and the one red is red because there I would take it with caution, right? Because you have this package depends on something else, and something else depends on this package. So you have dependencies in and dependencies out. And you need to deal with that with the points that we see, right? Address for especially in the adapt source sets for interoperability. So we would recommend keeping the number of dependencies low for these kinds of midway introductions. And a bit more specific, if we look at the onion architecture and the onion model, for example, it would be really helpful or would make sense, for example, to start with the domain core, with your domain service, where you have where hopefully you have separated all your infrastructural concerns from your business concerns. And now you could go ahead and say, okay, this our domain is really it's really maybe not so easy to understand anymore. Let's go ahead and transform this first, right, into a Kotlin. And then you have only dependencies going in, and you can test it individually and separate it. And that would be, for example, a good point to start. And you see the intermediate layer here, the app services, use cases, application services. They are these red package that we saw earlier, right? And then on the outer level, like on the integration level, controllers, ports, adapters, the infrastructural layer, that could also be a candidate to start gradually migrating to Kotlin. For example, you just carve out some REST endpoints and use the functional capabilities of Kotlin and implementing these, make it more concise, make it more readable, shorter, or other integration points like Kafka integration points and whatsoever. You can decide and should agree in your team on what parts are the ones to be migrated. How would we do this? It's not too complicated. First of all, ensure that you have automated tests and migrate them first. So if you don't have the test, definitely we would recommend implementing them, because this is the way how you can ensure that you won't break anything. And when migrating them first, then you also have the safety that part of your Kotlin stuff is working, and it's still working with your legacy code base that was supposed to be correct, right? And you should take advantage of your IDE, then transforming the tests and your production code. And after you also transformed your production code, ensure that the tests are green again. When taking the advantage of your IDE, doing these transformations, sometimes, there's this, for example, in IntelliJ, JetBrains IntelliJ, you have the possibility to convert your code to Kotlin. It's not always in the final state that you would wish for. You might need to do some manual adaptations. And with that in mind, yeah, I would say have a lots of fun approaching that stuff. This is it for now, for here. And now I would like to go and invite Gopal and Katja again to a small Q&A session. Yes.
So we've been monitoring the Q&A box and we have had 2 questions so far, and we would like to take this opportunity to basically answer them. The first one that was asked was, could you give us a reason on why you would want to have Java and Kotlin in the same code base? So, Thomas, would you like to answer this?
Let's go ahead.
Why having, can you repeat the question for me, please, Gopal?
Yeah, it is on, can you give us a reason on why you would want to have Java and Kotlin in the same code base?
Yeah, there might be the reason that you as a team, you want to evolve, you want to go for a more modern programming language. And in many companies, the situation is that you change existing code and you don't have the opportunity to go for greenfield, right? So at one point, and that alone might not be a reason to introduce a change in the programming language. But then the reasons that we heard earlier, right? You might want to convert some parts of the code to make it more concise, make it more readable, refactor it for understandability alongside with a new feature to be implemented. So if the code just works and doesn't need to be touched, and it did so like for the past 5 years, of course, don't touch it. It serves its purpose, right? We should only touch the code that requires it, and where we as developers require it to be maintainable by us. When we have this situation, then it can make sense to also take the opportunity as a development team, learn something new, modernize your applications, and profit from it from both sides. I hope this answers the question.
Yep. And somewhere along the similar lines, we have the second question as well, which basically asks on what was the biggest challenge for having these 2 code bases mixed up, like when you're having Java and Kotlin together, what could be certain challenges? And I think, speaking from practical experience itself, we believe that navigation to some parts of the code can be super difficult because the application would have moved when you're using Java and Kotlin. So it's hard to find certain things which were there in one place at one point of time. This is usually the case for larger code bases as compared to smaller projects. But if you have larger code bases, it might also become difficult to onboard new joiners on this particular project, because now you're not sure where is that particular piece of functionality that you might have implemented in Java and have moved to Kotlin, and you're trying to figure it out and navigate. So you need someone out there to help you understand on where this particular piece of functionality has moved or how this particular piece of functionality has evolved. I hope that answers the question as well. The next question that we have is, we often come across a strategy where people first use Kotlin for writing test cases, and once a team is used to Kotlin, they go all in. And do we think if it's a good strategy? Yeah, would you like to answer this particular question?
Yeah, so basically, I would say that what Thomas was talking at the end about, that we believe that this is a good way to start, because besides of team getting used to Kotlin syntax and so on, it brings additional safety. So basically you improve your test coverage, automated tests and so on. You make sure they are working, and then you can safer migrate if you're talking about migration, or write new Kotlin code, like functionalities that is necessary. So yes, we believe it's a good strategy.
I also think I like this approach also for the way that you don't have this commitment to all of it yet, right? You can profit, for example, from the capability that you can have spaces in function names, and you can better express your test cases and so on. And yeah, it's definitely a good way to get familiar with the language. Thanks for suggesting that also.
Yep. And another question that we're getting in is, what are the most native Kotlin libraries that you recommend? I mean, the first one that comes into my mind straight away would be, from a testing perspective, the usage of mock.
Okay, yes.
Yes, the usage of mock-K. As we know that, I mean, as some of you might already be aware, that there is this particular framework available to mock certain parts of your application when you're testing. You usually come across this library when you're testing your REST controllers or your services, or you need something to be mocked. And there is mock-K, which is native to Kotlin, which allows you to do better mocking as compared to the one which Spring provides you out of the box. That would be the first one that comes to our mind. And I'm not sure if there are other native Kotlin libraries like that, but we have a certain set or certain tools, or you could say tips and tricks, when you're migrating to Kotlin, and we would be sharing up or sharing more information on such libraries and such native language features that you can be utilizing for the same. And finally, we are also getting another question which asks if there are any studies out there that you can refer related to productivity gains and TCO reduction due to Kotlin instead of Java for convincing management or business folks. I would answer that by saying that we have reports that are published by JetBrains themselves. These particular reports try to advocate for the usage of Kotlin by providing numbers related to the number of developers that have adopted Kotlin in the most recent ages. They provide numbers related to how many developers now prefer this in terms of their usage. They do not have very specific numbers related to productivity, but I think that could be a good starting point in order to convince management that, okay, developers are using this particular language, they like this particular language, and it can improve your development experience. I think Katrina also stated it during her slides that it's developers who are the ones who are introducing this particular language into their development groups, into their teams, into their organizations. So the first motivating factor that you can push towards convincing your management could be that this is going to help me improve my efficiency. And that's the channel that you open first. We will be on the lookout for more such numbers. And when we send up a follow-up email, we could possibly provide you with more resources that try to answer this specific management aspect of it. I hope that answers the question as well. Yeah, and I'll give a few more minutes, maybe 1 or 2, if someone else would like to ask some more questions. But meanwhile, I would say that that's all, I guess. In any case, if you have any other follow-up questions as well, as I said, we will be sending a follow-up email when we share these particular slides. The slides will also have some additional content for you to explore on your own, including some tips and tricks, some known pitfalls from our own personal experiences that you can refer to. And just to summarize everything and to give it a bow on top, I would say we discussed the pros and cons of Kotlin when compared to Java. We discussed when to move to Kotlin. We discussed some strategies for getting started. And we also discussed about some best practices for migrating to Kotlin or when you're starting a new greenfield project. And we really encourage you to explore Kotlin further and consider adopting it in your development projects. Finally, if you would like to talk more about this particular topic, we are also offering free 15 to 30-minute consultations where we can understand your current development practices and provide you with suggestions. So you can feel free to use the QR code on this particular site and set up a call with us directly. It could be either Katrina, me, or Thomas. And as we conclude this webinar now, we hope you gained some valuable insights on modernizing your Java applications with Kotlin. So I leave this slide on for another 1 minute, for just in case if you want to see the QR code. And obviously, because it will also be shared, so you can utilize it later on. I hope to get an opportunity to talk to some of you. And until then, I wish you all a great week. And I would say thank you for joining us today. So,
Thank you.